Okay guys, welcome back to Infinite Math Help Squared. It's been a while. So the purpose of this video is going to be to give a confidence boost in graphing in general. Basically for like Algebra 1 or lower. And this video is definitely not going to talk about when you graph using the form of a particular equation or if you're going to use transformation tricks. It's going to ignore all that and just keep to basic tables. I've got just 3 tips right now that we're going to focus on. First is get to know the way the graphs look and behave. So what do I mean by that? I mean basically what you see here in this table. This table came from Calc with Tully Weebly. I'm going to link it in the description because I think it's a really concise and great chart of the graphs. And then there's also activities there too. So I'm going to link that stuff in the description of the video along with some graph paper so that you can practice. You can see that if you're graphing something simple like just y equals 2, it's a horizontal line. If it was x equals 2, then it's going to be a vertical line. And then look at all of these typical ones, like definitely linear, definitely quadratics, and then sometimes you're going to have to graph some of the others. But get to know what they're going to look like so that you can anticipate. Okay, so that's the first tip. Next tip, the next 2 actually go together. And then we're going to practice a few, and then that should be it. If we're not going to use the form of an equation to help us, if we're not going to use, the idea of transformations from the originals or the parents, then you got to use a table of some type, right? A table of values. And at the end of the day, let's say you don't even know where to start, then let's just keep it simple. Just use 0, 1, and -1. If you do that, then you're going to have something that can use right away. And then you're just going to have to adjust it as it kind of makes sense. So, and you'll see that here with us practicing. So let's see what happens when we plug in 0, 1, and -1 just for x. Let's find out what the matching y is, and then let's graph it. If I put 0 in where we see the x, 0 plus, actually, let's just put it in there right there. Here, 0 plus 1 is 1. The absolute value of 1 is 1, and then 1 minus 2 is -1. Okay, let's change it to positive 1. 1 plus 1 is 2. Absolute value of 2 is 2, and then 2 minus 2 is 0. Now, this actually worked out really nice, and I didn't plan it like this, but notice I have x is 0, and I have y is 0 in the t-chart here. And it says here that when we use a table of values, one of my tips is we want critical spots like the intercepts. Well, we've got both of the intercepts right now, so that's a really great thing. Not all graphs will have a maximum and a minimum, but this is an absolute value equation. So hopefully if you're using the first tip right now, then you're anticipating that our graph is going to look like a V somewhere on our coordinate plane. Okay, so let's go back to this and we're gonna plug in a -1 now. -1 plus 1 is 0. 0 minus 2 is -2. Okay, let's plot. We've got 0, -1, 1, 0, and then -1, -2. Now remember, it's supposed to be V-shaped. So this is where okay, I did the 0, 1, -1, and I've got the start of the V, but I don't have the whole V. Now you have to anticipate and adjust as necessary. So for example, I can anticipate that the V is going like this. Maybe it's going even deeper. But at the end of the day, what do you need? You need the points for the X's that are right over here in this area. This, what I'm highlighting, is anything from X is -2 to -5. We're going to plug that into our chart now. And that's how we're going to choose our points and then finish off the graph. I have to put this point back. And now we can come back in the table. Go back to that. We said, let's do -2. Let's go small and then go larger. If I put in a -2 here, this is -2 plus 1 is a -1. The absolute value of -1 is 1. 1 minus 2 is a negative 1. So it's actually, I see something repeating here, which we can expect with the v. Negative 2, negative 1. So let's see what happens. Negative 2, negative 1. Up, look at that. It's already started to go back in another direction. So this is good. Let's do one more point. I'm anticipating it if it's mirroring with this one on this side. And then I'm anticipating it being right there, maybe on the x-axis. Let's find out. Let's do negative 3, and then we'll call it. Okay, because that'll be enough points. That'll be 1, 2, 3, 4, 5 points. Let's put in negative 3. So if I put negative 3 here, then negative 3 plus 1 is a negative 2, but the absolute value of negative 2 is positive 2. 2 minus 2 is 0. Look at that. It looks like we finished our graph already, and that didn't even take that long. Negative 3, 0. And now just finish connecting it because you have the accuracy from below. And that's it. So 0, 1, negative 1 really helped us get started, and then we used what we knew about in general about the shape of an absolute value graph to choose 3 additional points that helped us finish the graph. Okay, all right, let's try a quadratic. For this quadratic, 0, 1, negative 1, I pre-filled everything for us so that we could get started. If I put 0 in here and here, I'm left with negative 2. If I put a 1 in here, then I'm going to get 1 squared is 1, and then, so that's a negative 1, plus 3, because 3 times 1 is 3, and then minus 2. This is actually the result of a 0, and I swear to you, I promise you, I did not plan this, right? We have x and y intercepts again. Now, this is a quadratic, so if you come back up here and you think about, oh, what am I expecting to see? I'm expecting to see a quadratic graph, which is a parabola. It's U-shaped, and it's going to either smile or frown. And it could be anywhere in the plane, right? So, and remember, we're not going to be thinking about here the form it's in or what transformations are. Those things help a lot. But remember, this is just a basic confidence booster. Let's get some basics down so that we could get a graph on no matter what. Okay, so let's plug in negative 1. Okay, if I put a negative 1 in here and square it, I'm going to get a positive 1. And then I get the opposite of positive 1 is negative 1. Plus a negative 3 minus 2, right? Because 3 times negative 1 is negative 3. This comes out to be a negative 6. Now, let's see how this does for us as far as what we see when we graph it. 0, negative 2, 1, 0, and negative 1, negative 6. We know that it's supposed to be U-shaped, and it's either going to open up or down. So what I'm anticipating right now is that it's doing this, right? That's what makes sense to me. And this is, I didn't plan this, right? But this is not always going to happen where our 0, 1, and negative 1 is going to be this helpful. But it is a really good starting point. Something positive, something negative, and then 0. Okay, so what do I need? I need what's happening over here. Well, what's happening over here is honestly between 2 and 4, maybe even between 2 and 5. Whatever x is over here, I'm going to get a corresponding y over here. And that's what I really need right now. So let's try, how about 2 and 4? And then we'll that should be enough. 2 squared is 4. And then I got a so this is going to be negative 4 plus 3 times 2 is 6, but I have to take away 2. Oh, this is interesting. That's actually 0 again, isn't it? Okay, so the way this is working out, so since this is hitting the x-axis again, this means that I don't have the maximum, right? When you when you think about what you know about the function itself or the equation itself, quadratics are supposed to have a minimum or a maximum. Because this is frowning, I know that it's going to have a maximum. I don't have that yet right now because right now this is flat, right? That's just a horizontal piece. So we're going to do two things. We're going to go ahead and get the 4, and then we're going to try to get our vertex. So then, yeah, it's got to be 1.5 because it'll be right between these guys. We should be able to anticipate that the peak will be like maybe right here somewhere. Okay, so let's plug in 4. So 4 squared is 16, but then it's the opposite of that. So negative 16 plus 4 times 3 is 12, and then minus 2. So 12 minus 2 is 10, and a negative 16 plus 10 is going to give us a negative 6, which is nice because we already had negative 6 in our graph. 4 and negative 6 is right here. Okay, nice. Now let's try 1.5. Okay, so if I do 1.5 squared, I'm going to get 2.25, but it's got to be negative plus 3 times 1.5. That's 4.5, and then minus 2. So we have a quarter. Nice. That's pretty much what we anticipated. I think, so 1.5, and then here's my peak, like right around here somewhere. And now you graph it. So I would say that the drawback to this method, right, the intention here is to give us a boost in the graphing in general, but the drawback is that you're going to have multiple points, 1, 2, 3, 4, 5, 6 points to get a really good accurate graph. But as you get used to it, it's not going to take that long. Okay, last one. This one's linear. It's just a straight line, right? Like if you come up here, hopefully you notice, x is to the first power and then y is to the first power. So this is linear. All right, so let's plug in the 0, the 1, negative 1 again. And let's see what we get. If I plug in the 0, I've got 3. If I plug in 1, that's kind of ugly because of the fraction 3/2. So how about we adjust it? Let's adjust it to 2, since the denominator is 2, and then negative 2. Let's get rid of that 2 then. Okay. If I plug in 2, 2 divided by 2 is 1, so this is 3 plus 3 is 6. Negative 2 divided by 2 is negative 1, times 3 is negative 3, plus 3 is actually 0, and what do you know? We ended up with our intercepts again, which is actually really beautiful. 0, 3 is here, 2, 6 is here, and negative 2, 0 is here. So this is really nice because it's a straight line. You only need 2 points, and you have 2 of those 3 points that we just graphed were intercepts, which is perfect. So I hope this helped, and good luck graphing. Let me know if you have any questions.